Okay, you can see the PPT. Yes, yeah. So with all the techniques what we discussed so far, like logistic regression, which is a regression based approach to classify or predict the future, and then decision trees where we can use rule based rules to classify the or predict the future, and the probability based approach navigation for the classification only, nearest neighborhood, which is instantaneous based approach to classify and predict the future regression, and support vector machines where finding a hyperline which can maximize the margin between the classes, and neural networks is basically a multi-layered approach which can take the parallel inputs data and try to give the best mimic of the data. So these are all the different approximations people will try to use in the classification in supervised models and try to find the best relations. As I told you that supervised regression is basically uh, try to find the best approximation to the given and input and output and try to predict the further feature. So why do we have so many techniques? As I keep on telling you that today we are in the era of machine learning, which is in the non-inferential nature, and we are trying to learn the relations from the data and use that relations for the predicting. So because of this nature we never know what kind of approximation works good for which kind of data. So maybe sometimes logistic regression works well, sometimes rules works well, sometimes probability approach based well, but we never know. So that's the reason there is a popular theorem. It says that no free lunch algorithm. So what people will do is in the machine learning, instead of building, because now today there is no problem for the computation, there is no problem for other algorithmics or anything. So what people try to do is, instead of trying to build only single equation, what they will try to do, they will try to use all these techniques in a pipeline. And based on that validation, which we will discuss in the next unit, what is the how to evaluate the machine learning algorithm, based on the validation they will try to take the call. That's why we need to know multiple algorithm how they will work. Now no, broadly how they will work, then they will take the. So that's what about supervised learning. Now we are coming to the next variety, next portion of machine learning algorithm, which is unsupervised algorithm. As I told you that the difference between supervised and unsupervised is, in the supervised we have label data and we have both dependent and independent data, but unsupervised we have only the data and it's more of explorative in the nature. We have the data and we need to predict the description or relations from the data. That's why it's called more of exploratory in the nature. So unsupervised algorithm, there is no dependent involved. Basically people will give the pattern of the data, we the input data, we see the input data, and based on the patterns we have to find the groups. That's the concept of unsupervised learning. And more some of the unsupervised learning examples are, as I told you, that segmentation. Segmentation is basically dividing the people into various groups. Like if you take your class also, people try to this fellow belongs to that group, we look a group, the five people look a group, these five people are a group. We will basically divide the people into various groups, even class or company, anywhere. How we will do it? Basically we see their styles or their lifestyle or habits, and where they are very close we tend to give a some kind of group. So these are all one group, these are this group people. That's what the concept of supervised learning. Unsupervised learning is basically we need to see the data, we take the data and see the pattern of the data, and whose patterns are very close, we'll divide them into various groups. So another classical example for the unsupervised learning is the segmentation analysis. In refer they call it the cluster analysis also. Most of the companies see any company, if they wanted to find a promo, if they wanted to give some kind of promotion or some kind of promo, they can't give for all the people. Earlier we used to see that a lot of telecom companies, they try to give some offer for the some of the value customers. So valued customers, how they will find the valued customer? They basically take the data, they see the patterns, they see the expenditure, they see how loyal they are. Based on that they divide the people into various groups. Based on the group they try to give the different offers. That's what it's very very popular algorithm. So the picture itself is explains what is unsupervised learning. uh, yeah, unsupervised learning actually two ways of unsupervised. One is the data reduction techniques, and second one is cluster analysis or data reduction techniques. So that could be association analysis, that could be recommendation analysis, and second one is cluster analysis. So data reduction techniques is nothing but if you have the data, you see the patterns of the variable and try to reduce the variable into some of the groups. That's called data reduction technique. Or you are basically trying to reduce the number of higher number of variables into smaller number of variables, that we call as the data reduction techniques or principal component analysis. That is one of the data reduction technique. And second one is basically association analysis. Association analysis is basically we take the people, we see the pattern of the people have it. Like if you see the Amazon, you might find always this similar people like you also bought. So that's the association analysis and recommendation analysis. And third one is the segmentation analysis. Okay, when we are discussing about preparing data in the second unit, I think preparing data for modeling also, we have discussed one method called filter method. Sorry, wrapper method. Wrapper, filter. What is the third one? Embedding method. Yeah, wrapper method and embedding method. So in the third method, actually the data reduction technique is basically one of the method where most of the times I think when you are today we are in the huge data era, you will get lot of variables which are correlated variables. Before you applying the model, you need to basically reduce the number of correlated variables to smaller number of factors. That's the data reduction technique. So it's very, very important. So coming back to our technique, today we are discussing about the principal component analysis or factor analysis. So as I told you that principal component analysis is nothing but let me see, can we take k means a principal I will finish the So as I told you that principal component analysis is like is a concept where we try to reduce the number of variables into a lesser number of factors, which is nothing but a combination of the variable. For example, as I told you, I will give you a simple example. You have like height and weight. So height and weight are the two variables. What people will do is instead of reading height and weight, which is very correlated variable, they will try to calculate a measure called BMI, correct? Body mass index. So body mass index is basically a factor which can derive from the two correlated variables into one variate, which is a linear combination of weight and height. So what I'm trying to do is basically the whole concept of the principal component analysis or factor analysis, sometimes they are interchangeably used, is try to basically you have a large number of correlated variables, and by the concept of principal component, you try to reduce the higher number of variables into lesser number of variables, which is the factor. The factor composite with the variables with linear combination of like regression. You have for every variable you will get the coefficient, and you basically try to find a variate which try to explain the maximum variance of the original variables. That's the concept of factor analysis. Understand? So factor analysis is usually data reduction technique. The objective of the factor analysis is to reduce the number of observed correlated variable into number of unobserved factor variables. So factor is unobserved. Body mass index BMI is unobserved. We can't see, but it will be derived by using weight and height. Height and weight are basically observed variable which are correlated. We cannot use the correlated variables, so two correlated variables, because it will affect the model. So in order to use the two correlated variables, what we are trying to do, we are trying to find a factor which is a linear combination of height and weight, which is called as BMI, which is unobserved. I mean, we doesn't know, but we know only height and weight. With the height and weight only we'll calculate. So that's how factor analysis. So what will happen by doing factor analysis? So by doing factor analysis, what will happen? The original n variables will be reduced into the m factors, which are uncorrelated. So it basically will reduce the number of variables from the model. Easy to apply, easy to understand also. So that's why the factor analysis is very, very useful. The summary is basically, if you have so many correlated variables, so you can just reduce the number of correlated variable into lesser number of factors by using principal component analysis. Basically, principal component analysis from your multivariate paper, you can understand how it will work. It basically find the eigenvalues. Based on the eigenvalues, you try to the concept of principal component analysis is very, you take the data, you basically try to visualize them into the lower dimensional space, higher data into lower dimensional space. When you're doing the lower dimensional space, you can find the interrelationship between the variable. If you want to see the relationship, you just explore them higher relation in the SVM, like non-linears. If you want to condense the data, you just explore them into the lower dimensional. Water కూడా మన పైకి వేస్తే ఏమైంది, స్ప్రెడ్ అయిపోయి రిలేషన్ వస్తుంది. కిందకి చేస్తే ఏమవుతుంది, గ్రూప్ అవుతుంది అనమాట. సో ఇఫ్ యూ వాంట్ టు గ్రూప్ ద వేరియబుల్, let the visualize the data in the lower dimensional space. So in the lower dimensional space we can understand their projections on the lower dimensional scale. By that we can find the which are very close to them. That's the concept of principal component analysis. So that's what the principal component analysis is very useful, like this, like in your data, these are all the variables which are correlated variable. When we try to explore them into dimensional, you can see the multiple similar kind of variable. On the lower dimensional you can see the pattern of the variable, which are this is the lower dimensional case. We can understand which variables are naming the factors. So I will, when you see the example you will understand. So that's what factor analysis. Let's go back to notes and I will explain through the notes also. Various. Yeah, data reduction technique. So on supervised learning, I know the cluster analysis, data reduction technique, dimensionality reduction technique. That's what we are discussing. One of the popular dimensionality reduction technique, the principal component analysis, which is used for the vector analysis. More critical details, you go to your multivariate paper and do that. The idea, as I told you, that we are trying to explore, we visualize the higher dimensional data into lower dimensional space. When you try to explore them into lower dimensional space, you will find the variables which are very close to each other as one group. That group we call as the factor, in very simple language. So factor analysis is exploratory technique applied for the data reduction. The object of the factor analysis is to reduce and summarize the large number of original variables into smaller number of the variables. That's the idea. The smaller number of variables we call as the principal components. And the basic idea of factor analysis is the data reduction technique to combine the one or more correlated variable into small factor, height and weight into the body VM, because they are very correlated. It helps to producing the lower dimensional representation of data by identifying the set of the linear combination of the feature. How you will get the factor? It's basically linear combination. BMI equal to 0.5 into height plus 0.4 into weight. So we'll get these weights by using the concept of eigenvalues. When you represent on the lower dimensional space, we will get these weights. Okay. Once we get the weight, we basically calculate the factor with the linear combination of the data. So these, so it helps the lower dimensional represent of the data by identifying the linear combination of the features which have the maximum variance. Let's say maximum variance explained. So the linear discriminant technique could be helpful in understanding the latent interaction between the variables in the unsupervised setting. So how do we do the factor analysis? To do the factor analysis, basically we have the following step. So as being we are working with the factor analysis, so only continuous variable only will work, because factor analysis essentially works with either covariate matrix or covariance matrix. So when we calculate the covariate and covariance matrix, when your data is in numeric or interval data, so that's what factor analysis ka. These are the steps. So the data is basically in the continuous variable, and the factor analysis, I think first we need to extract the factor, then we need to make the factors were meaningful or not. So that's why, as I told you, that we can only take the interval data. The critical assumption for the underlying factor analysis is they should have some kind of correlation. If you don't have correlation, we cannot make the factors. So the critical assumption of underlying factor analysis are more conceptual than science. In fact, some degree of multi-collinearity is expected. If the variables are only collinear, then only we can make the factor. If height and weight is only correlated, then only BMI makes sense. Otherwise, it doesn't make sense. So the minimum coefficients, the default, the minimum requirement for to do the factor analysis, at least some of the variables, like say we have 10 attributes. Among these 10 attributes, at least 5 to 6 variables should have the meaningful correlation. So for that, actually, we have a test called Bartlett-Shaffer test. This test is basically give whether the data is correlated or not. Okay. Then factor extraction. So as I told you that we will use the concept of eigenvalue concept. The factors are nothing but principal component analysis. So the factors will be extracted by the concept of principal component analysis, which basically works with the eigenvalue concept. So once you identify, first we need to identify what are the suitable data types. The suitable data sets of interval scale, either ratio or interval. And the second way, the minimum, assumption for the factor analysis. The assumption for the factor analysis, they should have correlated. At least some of the variables should have some kind of correlation. So to do that, we have Bartlett-Shaffer test. So spreadsheet is test. Based on that, we will see whether the data is suitable for factor analysis or not. Once we find that there are some attributes which are correlated, then we'll use the principal component method to extract the factors. Principal component method is basically try to export the data in the lower dimensional space with the eigenvalues, it will extract the factor. That's the principal component. The principal component analysis is an iterative process that usually requires the repeating the factor analysis to produce the number of times each satisfied. So, but what will happen in the factor analysis, there we need to do the rotation. I will explain through example in the next class. So today I wanted to give the class, by that you can think about this. So factor analysis, basically you have like 10 variables, you wanted to extract let's say 5 factors out of these 10 variables. So what it does is, first it will extract the first factor. The first factor is try to explain the 30% variance from the data. Okay, then the second factor try to explain the most of the variance which is from 70%. That means it excludes the first 30%. That's why we will miss some of the information with the other variables on the first factors. To avoid this problem, in generally people will do the rotation. So one of the famous rotation is the Varimax rotation. So this Varimax rotation is basically try to give the factors. So even though some variables see some factors, when we rotate, all the variables are able to see on the all the factors and try to give the maximum factor loading on the variables. I will explain through the example next week, then things will be clear. So as of now, what you need to understand is basically Varimax rotation is try to solve the problem of second factor is not able to find the variance which extracted from the first factor, but when we do the rotation on the geometrical space, all the variable are seen on the all the factors. Okay, that's what Varimax rotation. Once we have the rotation, how we will do is basically we will see all the factors and see which are loadings on the all the variables. Let's say we have 10 variables. Like when you say the BMI is a single factor, variables are two, but for each factor you will get the correlation for the two variables. Let me explain through a small example, then you will understand. So how do you do? Once you do the factor analysis, all the factors, and you will get a correlation matrix between the factors and variables, all the variables versus all the factors, and we see which are the factors are having high correlation. By that we will select that factor as that name. So I will explain through a small example, then you will understand. So basically, to wrap up the summary, so what you need to understand is basically factor analysis is a data reduction technique which can be used to find the reduce the higher dimensional intercorrelated variable into lower dimensional factors which are uncorrelated. So to do the factor analysis, we have the three steps. First, we need to understand the type of the data. For the factor analysis, the default data is either metric, that means either interval or scale. And what is the assumption required factor analysis? They should have minimum of some correlation. And we extract the factors by using the principal component analysis. And the principal component analysis will use the eigenvalue concept. And based on the eigenvalue one, up to that is the cutoff point. Based on that principle, we'll extract the number of factors. When we are extracting the factor, the first factor is try to explain the most of the variance from the data. Second factor is try to explain the residual variance of what is first factor is explained. So hence all the variables are not exposed to the factor. To avoid this problem, we'll do the Varimax rotation. Rotation is the some kind of rotation on the geometrical space where each variable will be seen on the each factor. So it will solve the problem. So once we have the factors and variables, once we have all the factors, then we basically try to find the correlation between the factors and original variables. Which are the variables are giving high variables, they we can refer as one factor, and the rest all as one factor. So basically that's what factor analysis. What I will do is today you guys you go through this. Tomorrow at the same time I will give one case study on the factor analysis, which is my MPhil topic. So we'll see on the factor analysis as well as k-means analysis also. So right now put this in your mind to get the context. Tomorrow once again I will give the brief explain about the factor analysis, and I will also show the one of the case study using SPSS. Right now I will show another case study about the factor analysis. Okay guys? Is it okay or you want me to show it right now? Can I show it tomorrow?
Tomorrow is okay.
Tomorrow sharp is 12 o'clock. Okay guys? Tomorrow probably the aim is to finish the factor analysis and cluster analysis. And Wednesday I wanted to take ensembling. Thursday I want to take random forest. And then we need to go on to, at least we want to finish the session in this week. Okay guys? Chalo. Bye bye. Have any questions? Ask me. అర్థమవుతుందమ్మా?